Assalamualaikum and hi everybody. I am Madam Noon. See you again. In this video, I will discuss topic 11, which is about the deformation of solid, and also few examples for the objective question that relate to this chapter. In this topic, there are two parts that we will discuss. The first part is about the stress and strain, and the second part is about the Young modulus. To distinguish between stress and strain, let's consider a rod that has uniform cross-section area A and length L0. When the force applied at the both ends of the rod will extend by the amount of elongation E. Because of that, we can define the stress as ratio of the perpendicular force to the cross-section area A. And for the strain, it is defined as the ratio of extension or elongation to the original length. The unit for stress is Newton per meter square and the unit for strain is no unit. From the graph of stress versus strain for a metal under tension, we will discuss about the elastic deformation and plastic deformation. So, take a look at the graph of stress versus strain. From the graph, OB region is known as elastic deformation. In this region, the material is able to regain its original shape and length when the stress is removed, but does not obey the Hooke's law if exceed point A. For point CDE, this is a region known as plastic deformation. In this region, when the stress increases, the strain will increase, and at point D, the stress is maximum and will decrease until the breaking point E. From the graph of force versus extension, we will discuss about the ductile and brittle material. And if you look at the graph of force versus extension, the graph is also equal to the graph of stress versus strain. Because of that, we can explain the ductile material, which is the material that undergoes plastic deformation before breaking, such as steel, copper, and aluminium. For the brittle material, it is a material that do not show plastic behavior or plastic deformation, such as glass. And the last one I just add on, which is elastic material, the material that undergoes elastic deformation, such as rubber. Now we will learn the second part of this topic, which is about the Young modulus. Young modulus is defined as the ratio of the tensile stress to the tensile strain if the proportionality limit has not been exceeded. From the definition, we can write down the equation for the Young modulus as stress over strain or equal to FL0 over AE. Young modulus is a scalar quantity with the unit of Newton per meter square or Pascal. From the table there, it shows that for the different material, the value for the Young modulus is different. This shows that the Young modulus depends on the types of material. To explain about the strain energy from force versus elongation graph, let's consider a wire which is stretched by a force F. Work is done on the wire, or elastic potential energy is stored in the wire. So from the graph of force versus extension until the proportionality limit, the work done or the strain energy is represented by the area under the graph. Because of that, the strain energy equation is given by half Fe. The unit for the strain energy is joule. From the equation of strain energy and graph of stress versus strain, we get that the strain energy per unit volume is represented by the area under the graph of stress versus strain. Because of that, the equation for the strain energy per unit volume is equal to half times stress and strain. The unit for the strain energy per unit volume is joule per meter cube. Now we will discuss the objective question that relate to this topic. Take a look at question number 1. Shape of the stress-strain curve for a material depends on the strain, strain rate and temperature. So the answer is D. For question number 2, it is possible while tightening the nuts on the wheel of your car to use too much torque and break off one of the bolts. This is happen when the shear stress exceeds the breaking strength. Because of too much torque, the bolt will break. For question number 3, when a wire extended by a force F, the extension produced is X. If F is equal to Kx, the value of force constant K is affected by... Okay, to know the correct answer, take a look at the solution. From the equation of the Young modulus, we rearrange the equation and compare the equation with the equation of F, which is equal to Ke. Because of that, when we compare the K, we know that the K depends on the Young modulus, which is represent the types of material, the cross-section area, and also the original length. So the answer is D. For question number 4, a metal part fails via fatigue. Why? From my research, for the definition of fatigue, one of the definition is the weakness in material, especially metal, caused by the repeated variation of stress. So the best answer for question number 4 is B, which is as a result of repeated application of the cyclic stress. For question number 5, figure shows that the same force is applied to the copper and aluminium wire which have the same length. If the Young modulus of aluminium is larger compared to the copper, which statement is true? So to choose the correct answer, take a look at the solution. From the information given, we know that the force, the initial length, and the cross-section area is equal between these both wire. Because of that, we will get that the extension of the copper wire is larger compared to the aluminium. So, the best answer is C. For question number 6, the strain energy stored in a wire is equal to half Fx if the applied force is proportional to the elongation of the wire. This is due to the graph of force versus extension, where the strain energy is represented by the area under the graph as long as the proportionality limit not exceed. Because of that, the best answer is D. So that's it for the discussion of the part 1. See you in the next video in the part 2, which is the discussion of the structured question solution. Please show your support by clicking button subscribe, like and share, and leave a comment so that I can improve and can produce more video next time. Thank you. Thank you for watching and I wish you all the best. See you.